Psydactic Residency Edition. I am Dr. O'Leary, a third-year psychiatry resident in the National Capital Region. I run this project as something fun for myself. When I get really interested in a topic, it's great to be able to just put something down on paper and then share it with other people. I'm not giving medical advice here, and I'm definitely not speaking for any other institution. Everything I say here is my own opinion. In fact, it's probably wrong. I am not a neuroscientist, and I'm only in my third year of psychiatry residency, so take everything that I say with that in mind. Today, I want to talk about the brain's Salience network. But first, I guess I need to define what is salience. Fundamentally, salience is a value judgment that determines where your brain is going to place its limited resources. There are lots of things that could draw its attention. The world is full of sights, sounds, smells, pressures, temperatures, stretches, and our mind is full of thoughts. Without a salience network, we wouldn't know what matters and what doesn't. We would just randomly scan our thoughts and the environment and hope that we were noticing something at any point in time that is important to, say, keep us alive. But random scanning is just a losing evolutionary strategy. We need something more targeted. When we see something moving in space, we need to be able to decide if it's worth watching. Is it alive? Does it have volition? When we smell something, we need to know if it might be toxic or if it's familiar, if it could be food, or if we could be its food. Failure to implement a more cautious movement strategy when you're approaching the edge of a cliff could result in dire consequences. While our attention networks help us identify details in our environment, like the cliff, our salience network helps us to determine what details are important. A cliff, I might fall. If 5 people are looking at you, 4 of them are smiling and 1 of them is scowling, then you need to be able to identify the scowling person as something needing your attention. Being able to identify that something looks different from other things requires your dorsal and ventral attention networks and, of course, your visual cortex in order to see the details. But to be able to care that something needs your attention requires your salience network. If you hear footsteps behind you in an abandoned house that you went into alone, then you better prioritize finding out what that is. It's your salience network that's used to prioritize stimuli, whether it's internal, like your thoughts, or external. It's made up of your dorsal anterior cingulate cortex and the anterior insula, which communicates extensively with the subcortical regions in your ventral striatum, ventral tegmentum, and your amygdala. If you can remember the last episode, I asked you to lift up the operculum of the frontal lobe and stare beneath. If you remember that, then you may remember that the insula was tucked comfortably underneath the operculum of the frontal lobe. The cingulate gyrus, or cingulate cortex, is that part of the cortex of the brain that's hugging your corpus callosum. Now, your ventral tegmentum and ventral striatum are midbrain structures. They're part of your mesolimbic system. What this means is part of your salience network, the cortical parts of the insula and the cingulate gyrus, are predominantly glutamatergic, and other parts, the ventral tegmentum and ventral striatum, are predominantly dopaminergic. So I'm going to shamelessly refer you back to episode 7, OCD Brain Space, where I discussed the corticostriatal thalamocortical circuit and how glutamate-responsive neurons predominate in cortical regions and dopaminergic and GABAergic neurons predominate in the striatal regions. So your ventral tegmentum and ventral striatum are important in reward and in motivation, hence the dopamine. But they're also important in aversion and avoidance. especially considering their connections with the amygdala. Your salience network, then, is integral in identifying stimuli and deciding not only if something is of interest, but what kind of interest it is. Should I explore more? Should I move toward and embrace it? Should I move away? Should I avoid it? Have I seen this before, and how did it affect me? The ventral striatum contains the nucleus accumbens, which you may recognize as being one of the key players in the mesolimbic dopamine system, including our reward system, and then consequently is a player in addiction. Clinicians often advise those with substance use disorders to avoid temptation because for someone who struggles with substance use, their salience network might assign a distracting amount of value to thoughts or perceptions about the substance or to planning for acquiring that substance. A paper from 2015 in Neurobiology of Disease by Liang et al. Found that the default mode network and the salience network have reduced connections in individuals with cocaine dependence versus the healthy controls. In more general language, this means that the part of your brain that's more self-referential and that adds social and past context to our thoughts, the default mode network, may not be communicating as actively with the part of our brain that's assigning value to stimuli in our environment. It seems to me that this might make it biologically harder for these individuals to think about the consequences of their decisions. Liang et al. Could not comment over whether this reduced connectivity was a result of cocaine addiction or existed prior to cocaine addiction. Now, let's imagine someone with schizophrenia who's trying to pick out salient aspects of their environment or their own thoughts. If you think about the diagnostic criteria for schizophrenia, we usually break them up into two kinds of symptoms, positive and negative. Positive symptoms include adding things like hallucinations, delusions, and disorganized speech or disorganized behaviors. The negative symptoms are avolitional, like a lack of motivation, a lack of affect, or a paucity of speech. These seem like very different kinds of things, positive versus negative symptoms. And even among the positive symptoms, a lot of them are very different kinds of things. Delusions are when you seem to assign too much salience to, say, our own thoughts or things we assume about our perceptions of the world around us, resulting in phenomena like thought broadcasting or paranoia or culturally derived conspiratorial assumptions like I'm being watched by the government or I have been chosen by God for a special mission. Hallucinations are unsubstantiated yet real-seeming internal perceptions. So they're different than delusions in that way. Disorganized speech and behaviors seem kind of like desperate and ineffectual attempts to affect the world around us. But avolition is a lack of interaction with the world around us, and it's hard to know what's going on inside of a brain that's not doing things or saying things. Schizophrenia itself refers to a splitting of the mind, or more broadly, a splitting of the self. A splitting of the self seems to involve the default mode network, which is the network that tends to do our self-referencing and helps us to have an identity. The default mode network was the first network I talked about in this series. Disorganized behaviors, on the other hand, seem to involve our executive functions, and I haven't yet discussed our executive networks. That's for the next episode. But how's the salience network evolved in schizophrenia? It seems like the positive symptoms, especially, say, delusions, are more likely to directly involve the salience network than negative symptoms or disorganized symptoms. However, avolition might be a result of an inability to assign value to otherwise salient social cues. It's obviously not a simple problem. Would we expect the part of our brain that gives salience to our thoughts or our environment to be extra connected or under-connected to other regions of the brain? It's not obvious to me, anyway. It could be that the salience network is overactive, assigning too much significance to transient details, resulting in, paranoia. Or it could be that it's underactive and therefore not properly assigning salience or double-checking whether something should be considered significant, so the rest of our mind is kind of allowed to run wild with unimportant details. Kowalski and colleagues in the Journal of Clinical Medicine in 2021 described psychosis like this. On a phenomenological level, aberrant salience is described as interpreting irrelevant as relevant, highly familiar as novel, having sharpened senses, keenness for things normally deemed negligible, or a sense of newly found insight or understanding. I love that quote so much, I'm going to say it again. Quote, on a phenomenological level, aberrant salience is described as interpreting irrelevant as relevant, highly familiar as novel, having sharpened senses, keenness for things normally deemed negligible, or a sense of newly found insight or understanding. Since the salience network has broad functions that work together to assign value to internal and external stimuli, and it is intimately involved with our reward system, we might suspect that some parts of this system might be overactive, while others are underactive. For example, the ventral striatum in some studies has been shown to be overactive in schizophrenia, kind of giving a sense of reward where none is warranted. The insula and dorsal anterior cingulate in some studies is underactive, which may explain why the rest of the brain gives too much attention to details that truly have no significance. They've lost connection with what is truly salient. In short, in psychosis, our brains reward us for perceptions, actions, and thoughts that have no real value. That is a very, very basic oversimplification of how the salience network might malfunction in psychosis. But none of our brain networks are alone. Among neuroscientists, there's this rising paradigm called the triple network model, and it posits that there are three main networks in our brain that are dysfunctional in most primary psychiatric disorders. These networks include the default mode network, the salience network, and the central executive network. In the next episode, I will discuss the central executive network. It's a network that sends tentacles out into the other networks of the brain in order to communicate and receive feedback necessary to plan and accomplish tasks, things that require strategy, that require prioritization and order. After that, I want to discuss how in a similar way that a family or a business or an administration can't function well without a balance of feedback from its members, none of these networks can function effectively without the others. Thank you for listening. I am Dr. O, and this has been an episode of Psydactic Residency Edition.